So today I'm going to introduce you to something we use frequently in statistics, which is hypothesis testing. The first one that we're going to do is what we call a one proportion z-test. Now this might sound familiar because we have previously done a one proportion z-interval. So the z is going to be used, z-test or z-interval will be used when you actually have a proportion. And so everything in this chapter is going to have to do with proportions. So we'll start straight away with an example. So go ahead and read through this and see if you think that this is strong evidence that the local rate is above the national rate. So your first impulse is most likely that you're going to do 376 over 400, find out that that's 94%, and notice that that is actually far above the 90%, which is pretty good. Unfortunately, you do have to do more than that because it's completely possible that this 94% is just due to sampling error. It doesn't mean that the building inspectors made a mistake. It can be just random variability. It can happen. So this actually is our p-hat. We will need that value. Sometimes you might want to use that just to see what's going on, just to see where your sample rate is, but it's not going to be enough just to look at that. We do have to do actually a statistical test. And as I said, the test that we're going to do is called a one proportion z-test. So a one proportion z-test, and actually any other hypothesis test that you do, we're doing several of them in this class. So we're always going to start off by forming a hypothesis. So we will do two things. We'll do what's called a null hypothesis and an alternative hypothesis. In this situation, the null hypothesis would be, and in pretty much every situation, you may have heard the word null before, but it generally means nothing. So our null hypothesis is going to suggest that nothing has changed. So it's going to suggest that the city smoke detector rate is the same as everywhere else. So you don't need to write this out in words every time. However, when you're first learning these, I think it's a good idea to write out the hypothesis just so you can think about what it is that you're actually looking for. Your alternative hypothesis is kind of what you're hoping. So usually when you have a question like this, they'll ask you something like, is this strong evidence or is there evidence? This one they're saying that the local rate is above the national rate. So our alternative hypothesis is going to just be that the local rate is above the national rate. So that's what the hypotheses are in words. Now we're going to actually write them out in symbols. So our null hypothesis is written as an H with a subscript of 0 or O. So in this case, we are going to say that our null hypothesis is that the population of the city has exactly 90% smoke detectors. It's the same as everywhere else. So this would be how we write our null hypothesis. Now our alternative hypothesis which we're going to write as H with a subscript of A, is going to be that the proportion of smoke detectors in the city is going to be greater than 90%. So make sure that you're using proper notation on this. The P is going to be the population proportion of the city. It's not of the whole country. It's just going to be of the city. That's what our population is in this case. It's the city, or city homes. And remember that population proportion is a P without a hat. The sample proportion does have the hat on it. So it's completely acceptable if you only write these two things in symbols as long as you define what your variables are. However, to be honest, on my quizzes though, I'll usually ask you to write a hypothesis both in words and in symbols, so make sure that you can also do that. So what we're going to be doing now is we are going to be testing our hypotheses. We are going to be seeing that what's going to happen if we assume that the null hypothesis is true. What are the chances that we can get 94% of our sample having smoke detectors? So that's what we're going to test right now. And I'll write out again what I just said. So that should help you out in a bit. But before we do that, before we go into all of the mechanics of this problem, I'm going to actually go ahead and check our conditions. And if you are really comfortable with the stuff that we did with confidence intervals and our conditions, you should be okay with this. It's the exact same ones that we did in the previous chapter. So we're going to start by saying that we know that this is a random sample. We're not just making this assumption, actually they told us that, so the sample is random. We also know that our success failure, our NP and NQ are big enough. So NP is going to be 400 times 90%, which gives us 360. That is much bigger than 10. NQ is 400 times 0.1, that gives us 40, also much bigger than 10. So we're good on those. The last thing that we're going to say is that we don't know this for sure, but assuming that this is a fairly good-sized city, we can assume that 400 is less than 10% of all city homes. If you want to write that you're going to assume that homes are independent of each other, that's fine. You don't have to in this case, but you can. The last thing I'm going to do as soon as I'm done writing down my conditions and assumptions is I'm going to say something like that you can use a 1 proportion z-test. Just make sure that you know the name of the test that you're doing. For this entire chapter, however, it's going to always be a 1 proportion z-test, so don't get worried if you are not sure how you can identify that. For now, it's only going to be a 1 proportion z-test. We'll do more later on, and we'll worry about that later. So we have our conditions done. We've named our tests. We've made our hypotheses. Now we're going to get to the actual work of the problem. So what we're going to do is we are going to use a normal model, and we're going to make the assumption that the null hypothesis is true. And remember, our null hypothesis was that the population proportion of smoke detectors in our city was 90%. So from there, we would like to find the probability that we end up getting this particular p-hat, this particular sample proportion. So we want to find the probability that 376 out of 400 homes have smoke detectors. So this is what we're actually doing. If you don't immediately understand it, that's okay. It's not anything to really worry about at this stage. Just kind of try to get the process down. And but if you understand what's going on here, that'll help you a lot in the future. If not, we're going to be doing this again and again, so you'll see many of these hypothesis tests. So now let's get to our mechanics. So what we're doing is we are going to make the assumption that the mean proportion, or the population proportion of our entire city, is 90%. So I'm going to put that right in the middle of my normal model. By the way, I do recommend that you draw a normal model here just to show what you're doing. I think it's a good idea. I am going to look for it on the tests and quizzes, and if you're taking the AP test, they're going to look for that too. So it's just a good idea to do it. So what we're going to do is we want to find the probability that we end up getting something greater than 94 or greater. So this is what we're going to do here. So this is assuming that we get a p, we have the original p of 0.9. So we have our p hat. We are assuming that our p is 0.9. We're assuming that our q is 0.1. We know that our sample size is 400. So the next thing I'm going to do is, making these assumptions, I'm going to find my standard deviation. Now, one thing to remember that's important is we're going to use the standard deviation with the assumption that our mean is 90%. So don't use your p hat here. So then once you work this out, you will get 0.015 for your standard deviation. So now we're going to make the assumption that, I know I mentioned this already, but I don't think it'll hurt to say it again, that our p is 0.9. We want to find the probability that our p hat is either 0.94 or larger. I will explain later on why we use greater than 0.94, so don't worry about that right now, but that's what we're looking for. We want 0.94 or larger. So you can actually do this all on your calculator. And if you're taking the AP test, I do recommend that you write out this notation. I think it's a good idea. In addition to drawing a sketch of the normal model, it definitely will not hurt. You can also write the calculator stuff, but it's most important that you do have some sort of notation that you do know that the p hat is 0.94. So I'm going to do 0.94. And you can go to any big number. I'm going to just be safe and go up to 99. I'm going to use that my mean is 0.9 and my standard deviation is 0.015. When I do that, I end up getting this value, 0.0038. So the chances of this stuff happening, 0.94, just randomly, is very, very small. So this value that we have right here is extremely important. You will see it mentioned all the time. This is called our p-value. And yes, you might notice that the letter P is used a lot in this chapter. It happens all the time, unfortunately. So you're just going to have to get all the P's straight. So our p-value is super duper low. You can probably see that. So what that means is that the chances of getting a sample probability like 0.94, if we assume that 90% of all homes have smoke detectors, is this small. So it probably isn't going to happen. So this actually shows us strong evidence that there is an increase in smoke detectors in this particular city. Our next step is the final one. We have 4 steps, you might have figured out. So our last step is to write a conclusion. So for our conclusion, we actually are going to always have 2 possibilities. I'm going to write them on the side. So your two possibilities, first one is you're going to reject your null hypothesis, which remember is H0. You will do that when your p-value is less than a certain amount. In this case, we're going to say less than 0.05. You might use 0.01 or 0.1, but for now we're going to use 0.05. Later on we'll use something different. That's your first possibility. Your second possibility is you don't reject H0. You're going to do that if your p-value is over 0.05. By the way, I'm just going to comment that you should never say you're never going to accept anything. You're never going to accept the null hypothesis. So you can't accept it. We don't have evidence enough to do that. We can't be 100% certain about anything. But we either are going to reject it or we're not going to reject it. So the best way to always start out with these conclusions is say something like, since the p-value is low, which in this case is very low, we are going to reject the null hypothesis. So it's always a good idea to write two things. First of all, you're going to mention that the p-value is low. Second of all, you're going to mention that you're rejecting the null hypothesis. That's your first part of it. The second part of it is to actually answer the question that they asked you. If you look back at the original question, they ask, is there strong evidence that this city has has a higher rate of smoke detectors than the national rate? So then you're going to answer that. You're going to say, yes, there is strong evidence that more than 90% of homes in this city have smoke detectors. And once you have that, you are done. By the way, you're gonna either end this, there is strong evidence that, and then after that, you're pretty much just going to restate your alternative hypothesis in words. So you're going to have two possibilities. And as I mentioned on the side, the first one is you reject it. The second one is you don't reject it. So this is our first type. Now, if the p-value is high, then the thing that you would say then is, you can say something like, since the p-value is high, we fail to reject the null hypothesis. Then you would say there is no evidence that, and then after that you would do whatever your alternative hypothesis was.